Okay, great. Just to start off here, it would be nice to know a little bit about the knowledge of Openstack here in the audience. Is there anyone who just heard of Openstack and is just here for, well, try to know what Openstack is? Yeah, okay, great. And the one who just, well, installed it and tried it in, well, a development environment? Yeah. And anyone running it in production today? No? Okay. Okay, great. Okay, so just to give you a quick background of me. I'm a technical background, an infrastructure technical guy. Worked with this for the last, well, 18 years. Started in the Solaris area with Sun, and moved, well, then worked with, of course, a lot of different platforms, a lot of Windows in the middle there, but I'm back now to almost only Linux again and open source, so that's pretty nice. So I've been around and actually built a couple of hosting platforms. One we started in 2001, more traditional hosting environments based on, well, it was, well, cutting edge when we started that type of service, a lot of virtualization with VMware and, you know, the traditional stuff. And now with Elastx that we founded in 2012, but then we started to work with cloud platforms instead. So the things I really enjoy to work with now is infrastructure as a service, platform as a service, and things around that. And that is very tightly coupled with DevOps, for example, and everything open source and performance is something that's always nice to have or nice to work with. So what we do, or what we aim for, is this: we work with platform as a service. Well, an Openstack, as you all know, is infrastructure as a service. But to be able to run a successful platform as a service, this virtualization or automation is a requirement to actually do that. And what is platform as a service? I'm actually going to show you just a quick video to show you the power of this type of platforms.
Kan inte du hjälpa mig att bygga en Java-miljö? Ja. Kan du göra det? Ja. Schysst. Kan man få en med MongoDB, kanske en lastbalanserad? Ja. Och en Maven? Ja. Okej. Kom då.
She's 2 years old.
Kanske kan hjälpa mig. Jag har lite bråttom nämligen. Tycker du det är kul med Java? Ja. Okej. Vad bygger du för miljö då? Ska den vara lastbalanserad? Flera? Ja. Ja, okej. Kan du göra det? Ja, 3 stycken. Ja, MongoDB, okej. Ja, en Maven-node, ja, bra. Är det klart nu? Ja. Ja. Snyggt!
Jag vill inte göra en gång till.
Tack Fanny, så duktig du var. Ja. Hej då.
Hej då.
Så vi hade inte övat innan. Okay, so that's the power of platform as a service. Now even a developer can provision their own environments and no one else has to actually be involved.
Kan inte du hjälpa mig att bygga en Java-miljö?
Ja.
Kan du göra det? Ja. Schysst.
Okay, so what we do is we aim for platform as a service. That's what we want to do. So we have one platform that we launched in the beginning of last year, and that's a platform as a service that is highly automated. It's very easy you're up and running in a minute, and just deploying code and databases and everything. That supports Java, PHP, and Ruby. But this is limited also. So we just have a number of databases that we support, and a number of software stacks, a number of application servers, and so on. So what we are moving into now is that we want a platform that we can host anything. And Openstack is a perfect fit for that, to have as a foundation for this. So we are running Openstack, and we are building that ourselves in our hardware, and we manage everything. But we are also, of course, compatible. So if we have a customer that don't want to use our infrastructure, want to run it in the US or something, we are also Amazon Web Services compatible. So. And on top of that, then we work with different type of platform as a service frameworks. So actually, it's a private platform as a service that you deploy on your selected infrastructure as a service platform. So I'm going to talk a short about a few of those options as well, and then we have consultant services on top of that, working a lot with DevOps. I work with companies that are highly work a lot with development and want to automate this and make it more efficient. Okay, so one of the big advantages with working with this type of highly automated platforms, and I have the personal experience as we have actually built the more traditional way to host it, and also built this type of cloud-based platforms. So these are the rules that we got before we actually performed this project, and it's in a small environment. One infrastructure administrator can handle about 20 machines. In an enterprise environment where you have some more automations, it can handle about 100 machines. And the best practice around this type of cloud environments, one guy can handle 2,000 machines or more. Okay, so that's the key why this is actually more, it's a cheaper service, of course, but if you want to build a private cloud like this, well, then you, of course, will need some volume to actually to benefit of it. But I guess that will be, that hurdle will be less and less as this type of platform matures and gets more and more easy to actually install and so on. But if you integrate that and take the advantages of actually with DevOps as well, and the times and the efficiency you get with integrating that into the platform as well, you can benefit that with much less volumes. Okay, so if we're going to start to describe the implementation we have done with Openstack now. So it's the first part. We have deployed it. Not everything is in full production yet. We started with a few parts. So we're using, for example, the Swift. We're using in production. But the other platform part, we are actually waiting for a few projects that we're waiting for them to mature a bit before we can put it in full production. And actually, Docker, that I'll talk about a little bit later, made an announcement just a few weeks ago that made us to had to change some plans around this as well. So I will talk about that as well. So on the hardware side, when we had the advantage of actually building this from scratch. So we could build an environment, a hardware environment that was purpose-built for this type of solution. So it was really, really nice to not have to buy the big, proprietary systems from the big vendors that cost a lot of money, and a big box that you have to pay a lot for, and just start with commodity hardware that can scale horizontally and so much more efficient and so much nicer actually to work with. So these are the type of hardwares that we're using today. Everything is very, very stripped down, and we actually did quite a big job in talking with a lot of the major vendors out there. We talked with IBM, HP, Dell, and so on. They didn't have anything that actually fitted. They are still stuck in the mind that it's the enterprise and full data center functionality. They build in so much shit in the hardware and automation and ID rack and stuff that we don't need. We don't want it at all. So we actually bought a few Dell machines. This is actually a Dell machine, but because they had a cloud series that they recently terminated as well. So that's, well, I don't get it. So now they don't have anything. So this, but we still use these type of machines. I never liked blade servers. Always like this standard commodity machines, and this is quite nice form factor. It's a 2U machine, and you have 4 servers, and in each of these machines we can now have up of 1 terabyte of RAM. So it's pretty powerful machines and extremely compact. And these are typical storage nodes we use for Swift. So it's a 4U enclosure, and it's 4 machines. And in each machine we have around 40 terabytes of capacity, in this capacity. So also pretty nice, very high density. So in a single rack we can have a lot of customers and a lot of data. Otherwise we're just standardized. We have dual 10 gigabit network to everything, just not to have any bottlenecks anywhere. On the block disk side, we use solid state only. So this is the type of storage system. So this is actually something that we bought because we thought it added some value that the pure standard Cinder with LVM and everything didn't bring us. But it's the same modern type of how you scale. So there's a single U nodes, and each node you pop in, you scale both in capacity and IOPS. And the blocks are spread automatically over all disks and between the nodes, so we can pull out the node without affecting availability and so on. Yeah, that's about it. It's just a intro from the hardware side. So why did we choose Openstack? Well, one thing was that we needed this type of infrastructure as a service automation. But there are a number of projects out there, so why did we choose Openstack? Well, one demand, of course, is that it was open source. I also worked with VMware's initiative, vFabric, and that was not a very nice experience. It's very expensive, and it's not easy at all to set up, because they bought a lot of companies, and then they brought it all together, and now they're trying to integrate everything. And it didn't really make sense when you started to dig in and try to set up everything. One key thing that made us choose Openstack is the number of contributors, and also the number of major contributors from the major vendors as well. And also that it is complex, but it's also very customizable, so we can do actually almost anything we want with it. We really like the Swift product, and it's sort of AWS compatible. So what we learned now when we installed it and run it in a production environment is that it's actually very easy to install. Just a simple, if you want to try it and do a development, the dev stack, for example, it's extremely easy. Just set it up and everything works, and that's fine. But when you actually want to do it in a production scale with the redundancy and the number of machines that you require for scaling everything, it's fairly complex. And we also made the decision not to buy the pre-configured stack from OpenStack, Mirantis, or any other Red Hat or so on. We built it ourselves, and it's a lot of work, but we learned a lot. So instead of just having a consultant coming in and helping us setting everything up, what happens if something goes wrong somewhere? It's a lot of parts to learn, and the best way actually to learn it is that you have problems. Then you really need to dig in and find out what the problem is. And we haven't, almost all problems were not, just ran into a few bugs, a couple of bugs maybe, but everything else actually was about configuration files and the number, where to put the configuration files and the modules and which nodes and so on. And it's pretty complex, and almost all guides out there are just talking about a single node, or maybe 2 nodes or 3 nodes. But then when you're scaling out, you maybe have 10 nodes just to manage the base infrastructure. it's quite hard to get good guides and good best practices around it. Yeah, and we also found it that so far it's been pretty unpredictable when you're doing updates. Doing a database update in Keystone from one version to another actually you want to do it rolling, so you want to take one offline, do the upgrade there, test that, and do the other one. But when you did that, it also updated the database schemes, and that made the old environment stop working. So if you want to do this in full production, you actually need to do this with the same type of redundancy and number of nodes to test it before you do it in actual production, so you actually know what happens. A bit of advice there. Okay. Another thing is that we love containers. So everyone here have you heard everybody about Docker? Is anyone who doesn't know at all what Docker is? And a container? Okay. Yeah. Have you anyone who have tried Docker? Okay, great. Okay, Docker is a container technology. And why we like containers and our other platform that we built is container-based. It's a lot faster, a lot more efficient, and so on. Traditional virtualization is this, you have the server, a host OS, a hypervisor, and on top of that you're virtualizing a new hardware. On top of that you need a guest operating system and so on, application, the whole stack. In a container you just have a single operating system, and you just have, containers on top of that instead. So it's no overhead in binaries, it's no overhead in hardware virtualizations and so on. So it's a lot more efficient and a lot faster anyway. So the goal for us from the beginning was to build the Openstack platform and only use container technology as the hypervisor. So what do Docker do, and what is Docker solving out there? So Docker is solving the problem. This is the problem we have. We have a number of software stacks out there that you want to host in a production environment. But then it's a lot of different environments as well. It's your own development environment, test environment, and production, and so on. Maybe public infrastructure, private infrastructure, and so on. And so it's a lot of compatibility things you have to keep in mind. And you can compare that with the shipping industry before pre-1960s. Then they shipped in all different formats, and they want to ship that in different ways, and they had the same problem. So what they did was to start using containers. So it's a standardized format, you can just ship in a container, box it in, it works all the way, very easy. And Docker is doing the same thing for IT. So if you have an application that is running in this container, it will run no matter what type of infrastructure you're running on. It will run the same way if you run it on your local machine as it will on the production environment. So it's extremely portable, and all the other advantages with the efficiency of using a container. So what I would advise you to do is actually try it. It's Docker IO if you want to go in, and this is just, you can have if you're on a Linux machine, you can just do this string and it will install, for example. This was an Ubuntu example, for example. The disadvantage is that it's only Linux and Mac right now. So it's a Windows, top left. There are other container technologies that we use. OpenVC, for example, also container technology, but it actually also supports Windows. Okay, so Openstack have two different integrations with Docker. Okay, this is what we wanted from the beginning. We wanted to directly integrate, so we wanted hardware nodes, Docker on top of that, and then we want to provision these OpenStack instances on top of bare metal, just with Docker running on it. So Docker actually has a Nova API and the Docker Virt driver, and also integration with Glance for handling their images. And they're talking against the Docker API, and then you can manage the containers on top of that. So that's nice. It looked very promising. So what Docker announced just a few weeks ago was that this initiative, the Nova API or the Nova integration, will be dropped out of the core Openstack. So that is moved out now to well, the side projects, development projects, the hang-around projects. And but they are introducing this integration more. This has been available earlier, also as an external plugin that you can install. But this will be part in the OpenStack core from the Icehouse release. So then they're just using Heat instead, and a plugin API for that, and then you can manage Docker containers through Heat. But the problem is that we don't get the efficiency of running Docker on bare metal. So what we have to do now is actually run a standard hypervisor like KVM, and then on top of that, those virtual machines, we can still use Docker. So it's still nice because you can use containers, but it's not as efficient as we wanted it to be from the beginning. You can run this. We have evaluated this. The problem is that you don't have support for Neutron, and you don't have support for Cinder yet. That makes it impossible for us to build a public service around it. If you're going to build a private service where you have control of everything and it won't be shared, and security is not an aspect internally, then you can go with this approach. But for us, building a public service, there's no way. Hopefully, it will mature and maybe get the support in the future, but we don't know if it will be 1 year or 2 years. So we had to revert and go with this instead. I'm actually going to just show you a few Docker commands and so you just get an idea on how Docker is working. Okay, so now I'm in a guest machine that is OpenStack guest machine, and it's just an Ubuntu image, and I just install Docker on it. So then you have Docker ps is the command for just listing the running containers, and we have no running containers right now. So if we want to start an Ubuntu machine, I can do Docker run TTI.
I don't know what to spell.
Yeah. Dicker, that's nice. Docker run and I can just do this. I want to do an ls in this container. Okay. So now you saw it. We started a container, did an ls, got the output, stopped, and wasted the container. So that's how it's tens of a second or hundreds of a second to start a container and then stop container. So that's how fast it is. If I wanted to do it and go in and do something, I can do run a bash session instead. Do it interactively. So now I'm in a container. So I could do something that I normally wouldn't do, for example. Okay, that would be a problem for us, normally. But in this case, I can just, well, exit the container. The container is gone, start a new one, and it's back. I didn't actually show you that it was gone before, but can do this again. Gone, exit, new, it's back. Okay, so that's the power. So what they're using a number of images. Exit this one, and so I can do Docker images. So these are the images that I downloaded. So Docker has an index, it's a big central repository for images. It's a lot of people build in there as a number of official releases and also a lot of homebrewed ones. So you just do Docker pull whatever image you want to pull down. So if zeros I already have, but you can get an idea. So seeing that we have the images and the layers, and it's downloaded, and we have it here, and then I can start it and use it. You can also build this private registry, so you can have a private registry for images as well. So what they're doing, they are, for example, the Ubuntu image here. If I'm starting based on the Ubuntu image and do changes, of course don't mess up the original image. So everything is stored in a layer. And when I do a change, I can apply those changes in that layer. And then I can choose to discard it with just stopping the environment and then it's gone. Or I can use the commit a save, and then it's stored and I can reuse it and start it over and over again. So I can have 100 machines running from a single image, and the only thing that I need is the blocks for the different file changes each container is doing, and that is stored in a separate layer for each container. So if I'm starting Ubuntu here, and I'm doing copy user bin kill, it is bin kill to the root, then I do a detach from this one. So now I did a detach and I didn't stop, so I can do docker ps. So you see this one is running, it was running for 26 seconds. And then I can do a docker commit. And that's my name. Okay. Now the Docker images. I can see that I committed a new image that is my own Joachim Ubuntu image. And I can also do, and this is a new layer, so it's just a few bytes of data. The virtual size is still 200 megs, but I can do Docker history. So I can see here, I can also see the changes that I've done. So the base image is still the Ubuntu image, and the changes I've done was just 18K. So that's very nice for a development environment. You can spin up a lot of machines. It's very fast, it's very efficient. It's you have full operating system, so you can do whatever and just reset and start over. So that's the quick intro of Docker. Okay, so a number of projects that we are working on to automate this on top of Openstack is one project is Solo. This is just under heavy development, so this is nothing we would run in production now, but it's a very interesting product that we will keep in mind. So what they're doing is just taking the whole life cycle of a project with Docker and tightly integrated with Openstack. Dice is another one, but that one leverages Chef, a combination of Chef, Docker, and Heroku build packs. So if you used and working with Heroku and want to do it and host it yourself on a private or maybe a local hosting provider, this is what you can do. Dice is something you should check out. Other things that's really nice that we like is Packer.io, a tool for actually building images. So you can have a base image and just build that for Amazon, and want to build it for Openstack, and want to build it for VMware, and it's a tool to handle that in a very easy way. And also CoreOS, it's a Linux operating system purposely built to run in this type of cloud environment where you can automate everything in a great way. Okay, so let's take a look at the Openstack installation we have today. Okay, so this is the normal Horizon dashboard that you can see here. We sign in. So I have a number of instances. This is the instance that was running a Docker that I worked with. I won't look into much. It's pretty standard. The thing that we have that's pretty nice on the volume side. Here I can actually create volumes with different type of performance volumes. So when I do this, it's all based on SSD, but we can set the quality of service. So here I can say, okay, I want a volume that performs with 1,000 IOPS or 5,000 IOPS or 10,000 IOPS volume. And that's what you get, and you just say the size and attach that to your virtual running machine. So that's pretty nice. But the thing that I'm going to show you, because all this integration that we've seen with Solom and DICE and so on, everyone is using the orchestration plugin or tool in Openstack. So everyone is using Heat, this orchestration part. So here I can deploy and manage my stack. So if you're going to do an OpenStack installation, I think this is the way to start. Just not start to manually install machines and your software. Start using that and deploying with Heat from the start, and learn that from the beginning, because it's very efficient and you will save a lot of time in the future when you started to build these templates, and you can reuse them over and over again. So that's pretty nice. Okay, so I'm going to show you a couple of templates. First, we can just do let's deploy just a single node. This is an Ubuntu machine, and the only thing I'm doing with this is installing Docker and making it ready for enabling the public API for Docker, so we can automate around that. So the easy way, if you want to use the web view, you do cut and paste, and then you're up and running, and just set the name on it. Docker node. Password, and it's up and running. Okay, so now deploying this. Okay, so here you can see we're deploying this node. The only thing I've added on top of this node is then a port, because I'm adding a public IP, a floating IP to this machine as well. And if you're going to look at the recipe or the template for that, is that you saw it was a formula. There was which network you want to fill in and everything. That's just pre-configured, but it's easy because you can just go in and change the network if you want to deploy it to another, attach it to another network, and so on. And here's the resource. I'm doing the image. I got the image from up here, where I set it to image string. This Ubuntu image was the standard choice. I just went with the standard choice. And added my key, and this is just a script that I run when the machine is up. So I installed Docker and enabled the public API, the API, so I can automate it, and the ports, floating IP, and then I have an output that just describes what's done. So I'm going to go in and look at the node here, for instance. Docker node. This is the one that's building right now. Okay, it's done now. So here you can see that it did run the script there that I set it that it would be. So look in the orchestration again. Docker node, and here it is. Okay, machine, and well, very simple one. So the next step would be, okay, on top of this now I can add a lot of containers, of course. So run new stack. Stack name, containers, password. Okay. So the last one took maybe a minute or 1.5 minutes to deploy. These are containers, and it's done. So now I deployed 20 machines in just a few seconds, and it will take the same. Well, I can terminate it as easily, and I can also change the heat template. So if okay, started with 20 machines. Okay, I only need 10 machines now. Then I can just change my, let's see, just 10 machines here. Now my stacks, containers, change stack, next. Update. So now it will just compare the two templates that are injected and say, okay, what's the difference, and make those changes. So now the only thing it will do is remove 10 containers. So it will only be 10 left now. So if you overview here, I can see that I have the resources. I have now 10 containers running. And in the events list, I can see that the last thing it did here was deleting a number of containers. Okay, the last thing I'm going to show you as a hit demo here is doing something that has some more relations. So this is a load I think it was 4 nodes, 4 nodes and a load balancer connected to those nodes. So launch stack. Openstack. Topology. Here you go. You can see that the nodes are building here, and I can actually do like this. And if I move it around like this, it looks like a man dancing with a funny hat. Okay, so this you can get stuck with and do nothing, and you can just play around with this instead. So it's very elastic, and you can't get them tangled. They always come out nicely. So it's nice. Yeah, so that's just a quick demo, just to show you a bit what the platform can do and what you can do with Heat. And of course, you can make this as complex as you want. And yes, a very important thing is that if you worked a lot with Amazon, how many is running or working with Amazon today? Yeah, okay. Yeah, if you have their orchestration templates, they are compatible. So you can actually take orchestration template from Amazon, just use it at Openstack. Of course, you need to adjust the instance names or image names and so on, but otherwise it's compatible. So that's pretty nice, and that's very actually important thing, I think. So yeah, that's about it. So questions? Yeah.
What kind of repository do you suggest using for the Heat templates? Like, where would you suggest keeping them? Or
I would use like a GitHub.
okay,
That's
so
pretty nice because
like
you can
text
have
files.
you have version handling and everything on it. So.
Okay,
And it's easy, and it's also easily automated if you want to automate, and you're doing a type of platform as a service layer on top of that. Git is one of the most common integration for repositories as well, both for configuration files and also for your development projects. So that kind of makes sense to use Git.
Okay.
Yeah. Anything else? Everyone was got it. Great. Okay, we are going to do the remote session now with John, who's the product team leader for Cinder. And so we can, stretch our legs, grab a beer, have a sandwich, and we will prepare everything here for the session.